Well, thank you all for inviting me. It's a pleasure to be here with you in Vancouver. I've been here once before. It was a pleasant time, but it's 20 years ago, so I'm glad to be back. I was excited to see all the new build-up in Vancouver, and it's great to see many of my old Arctic friends. Some of you might remember Jean-Claude. I used to do my PhD work on deep convection in the Greenland Sea and done many things since then. Today, I think this talk follows on greatly in the agenda and also in the topics that were outlined before. I want to give you a bit of a perspective from maybe an outsider. I don't work so much in the Arctic these days anymore, but I do work on issues with observations and also on issues on global sustainability. So I want to share some of those international developments with you to maybe give you some ideas about how you might want to progress over the next 3 years, and 3 days actually. The next slide is a bit of a sad slide, and I want to actually dedicate my remarks here to one of a great polar explorer and observer, Eberhard Fahrbach, who unfortunately passed away just 10 days ago. At the age of 65, he battled cancers unsuccessfully, and that's just to remind us things are finite. And I think Eberhard should be well known to most of you. He's been such a good force in polar observing, in community building. He has, over the last 4 years, managed the Polar Stern research activities, which I think several of you might have personally benefited from. So I just wanted to take that opportunity to remember Eberhard with you here. The agenda of my presentation will rove around a bit of your territory. That's an old slide of the implementation of sustained Arctic observing networks. And I want to set that into perspective in some of the global new thinking about science programming under the label of Future Earth. I want to share with you some of the developments in global ocean observing systems, which might be giving you some ideas, and also say a few words about sustainability. Now, I'm using a particular document here that is part of the record, and I'm using it as an example for Arctic observing. It's a particular document that focuses on ocean observing, and it says, why do you want to do ocean observing in the Arctic and sustain in particular? And as the previous two speakers have said, it's really, we're now thinking it more as a multi-stakeholder activity. That is, we as the scientists are certainly a user of that system, but not just us. It's seen to be a service to society needs. And some of the reasons given in that document are like those: industry, energy, and economic development in the Arctic arena, conservation and natural resource management in that system, global climate sciences. Peter has given you some of those aspects, and shipping happened to be singled on that particular document. So there's many reasons why you might want to engage in the Arctic, and in particular in observing activities. But the point that is made here particularly, and I think Peter made it too, it's not just for us scientists to understand the system, which is very important, but it's actually we want to make that knowledge available for those people who live there more than maybe I do, but some of you do. So it's the Arctic societies. I particularly like this graph that shows the different groupings of the sort of First Nations, as you would say in Canada, of the Inuit, of the Eskimos in the Arctic region. And that is sort of a view of the Arctic societies of changing a lot. That's the traditional ones. And I sometimes like the way that the group of Earth observations is going about making arguments for observing around the globe in general, or maybe in the Arctic in particular. And if you look at the group of Earth observations framework, you will not find an Arctic group there. You don't even find an ocean group there, which I was very upset about. But it is what they do say, aren't you doing all of this ocean observations, Arctic observations to the benefit of society? And they give you some aspects of why you want to do it. Particular aspect could be overall health, which I do understand is an issue in the Arctic as well, climate as mentioned, food supply systems, biodiversity, water, weather, and so on. So there's many benefit areas that you should always keep in mind. What are the benefit areas of the kind of agenda that we want to look at the next 3 days? Many of us, maybe all of us, who are concerned a bit about the future of our planet are engaging in this agenda. It's the Rio Plus 20 agenda about sustainability. And there's different groupings that are thinking about that. I'm part of the Sustainable Development Solutions Network, but there's others that you can think about. And I looked around the web, and I like that particular document, Securing a Sustainable Future in the Arctic, in engaging and training the next generation of Arctic leaders. I hope they're here, or at least some of them. But if you look at the formal process that comes out of the Rio +20 process, and the Sustainable Development Goals is the frame within which that gets developed, you certainly will not find reference to the Arctic in any of those goals particularly. It's for the planetary system seen as a small part, it's an important part, so you gotta have to think about how to engage in these frames. Now, sustainability usually revolves around a couple of different pillars. Maybe the top one here, the environmental sustainability, is what drives a lot of people in this room, with the Arctic being a particular case. But there are certainly others, peace and security, inclusive development, and certainly economic development are certainly agendas which are with us on the planet. And I think, as Peter was said, I'd like to understand over the next 3 years, so then what are the sustainable development solutions in general for the Arctic in particular? Where are the opportunities? Where are the Arctic futures? And I think for the observing community, if you identify where they are, you might want to be in a position, how do we measure progress? If we develop better or build up more resilience, can we measure that and help those who are engaged in that agenda to see their successes in the environment? Now, next up is a bit of an international research framework called Future Earth, which is trying to advance the science agenda behind that. And the first thing, which is a bit different to how business was before, is that we're now trying to set up these research frameworks on more shoulders, as it were. I'll show you the old Global Environmental Change Program in a second, but this group is here, the Science and Technology Alliance for Global Sustainability. And what I want to point out, there's players like ICSU, the International Council for Sciences, for those who know these acronyms. But now you also find the International Social Science Council as an equal partner. Certainly WMO and UNEP, these are known quantities. But then UNESCO, the educational part, United Nations University, so it's an educational agenda. But what we didn't have so much before is the ICFAS and the Belmont Forum. These are two groups of funders who are actually part of the sponsors. That is a little bit new to us in the science. We didn't have our funders to be part of the sponsors. And I'll show you in a second why we think that is maybe a good thing and maybe why a few others ought to be answered. I know Paul Holtus is here from the business side, and maybe those kind of groups might add to the alliance in the future. What is Future Earth? Future Earth is sort of the next evolution in global environmental change programming. And maybe the acronyms that are on this chart are somewhat familiar to you. In 1980, the World Climate Research Program was started, where Access and CLIC used to be part of. That should be known to the Arctic community. I work in CLIVAR, and there's GVEX and also SPARC. Then the Global International Geosphere Biosphere Program was started a few years later. The Diversitas, the biodiversity sort of scientific backing program was started in the 90s, and also the International Human Dimensions Program, taking and looking into social sciences much, much later. They together, around 2000, formed the Earth System Science Partnership, and all of that collection of acronyms, names, and all of these groups are merging now into a new framework starting now and really be operational next year, called Future Earth. Why Future Earth? The idea of Future Earth is to provide the knowledge required for societies around the globe to face risks posed by global environmental change and to seize opportunities and a transition to global sustainability. Same motivation as for your Arctic groups to get together. It's you know the system is changing, there are risks associated with this, but Future Earth really is interested in opportunities, and in particular in transitional science. As we were thinking about the research framework, we wondered how it should be set up. And we really think it should go from fundamental science, the deep drilling in various communities which require some global sort of partnerships, as we have needed in the Arctic because it's so hard to do, right down to what we might call actionable science, that is the kind of science that informs decision makers and the public. On a global, and on issues like global sustainability, we certainly need to focus on questions which are hard to answer. The local question that can be dealt with in local communities are better dealt with the local communities, but those things that scale around the globe or are too hard to do without a framework are the ones that should be under global programming. And I will speak a bit more about co-design and co-production of knowledge. That's a particular way of organizing and arranging your program, and you might want to think about that as you move forward. And Future Earth in particular integrates natural, economic, engineering, arts, humanities, and social sciences. And I think the Arctic community has in some way leading a way or have been very good citizens in that for the last decade. So that shouldn't be news to you. And regional to global scale, you could say local to regional in the Arctic context, that isn't news to you either. What drives the research framework is things like this. Again, nothing new to you. We certainly have human and natural drivers towards the environment. We're interested, this community, a lot in global environmental change. Some of it is naturally, some of it is human-driven. If your environment is degrading, it has impacts in human well-beings. And as human well-beings deal with impacts or want to develop, you generate a new sets of drivers. And sometimes this circle can be a vicious circle in some areas. So we're thinking about the pathways to sustainability might not be on the circle. It might be new arenas that we have to go into. And that's what's the interesting frame here. Cross-scale interactions, local, regional, global. And at the planetary scale, we think about development has to be within Earth system boundaries because there's only one planet, as we know of, that has to sustain a lot of us. Co-designing. There were some references made here up to now, but I want to go through this a little bit more slowly. There's quite a bit of work in modern or this current in vogue research programming. And the co-design goes as follows. In the initial phase, you have a debate between the scientists, that's most of us in the community, with what you might call stakeholders. And in particular, I want to single out here those you might call users of your information. It could be operational agencies, development, could be policy, but also funders who are meant to fund the research. And in the co-design process, you sit around the table with these 3-4 bodies and talk about your priorities before you decide which they will be. That system is run by the scientist. You are the conveners. You have this decision power. But we think it is important to, before you settle on your science questions, think about, are the users happy with maybe what you're going to research? Is the frame that you're asking the question the right one? And is somebody actually interested in funding this? Because otherwise it's not so helpful. Now, once you've set up the questions, then comes the production of information, and quite often that is really more in the scientific domain, but maybe not exclusively. There's also research done in corporations and governments that you might want to take note of or involve in the production of information. And as importantly, as you get towards a solution space, if you find a solution, if you learn a system better, sort of make that knowledge available to the broader communities, again, something that you want to communicate to the users. And it's very helpful if your users already know what you're doing, because then that link is already established. And it's going to be very easy to disseminate the kind of findings that you are having. And I think in the Arctic system, Peter mentioned urgency. Having an efficient system is a good thing. So, and this is seen to be at least as efficient. Future Earth is thinking about its research agenda, and they came up with very simple 3 big research themes. One is called Dynamic Planet, the other is called Global Development, and the third one, Transformation towards Sustainability. 3 topics only for this big program. Now, I want to give you a bit of a preview of what's in them, or could be in them. It's up to you, the community, to decide. So, Dynamic Planet. These are the kind of approaches and models you might be thinking about: straits and trends, critical zones. States and trends, that's observing right there. So that's sort of this community. But it's also using your observations, your models, approaches to project out the environment. It's about drivers, observing societal systems, thresholds, understanding a lot, and also critical zones like at polar regions that you would certainly highlight, coast, I might highlight, tropical forests, and a few others. Global development. I think this is about planetary stewardship, if you want to call it like that, stewardship of resources. It's assuring clean air, mining materials, biodiversity, ecosystem services, the life system for us of the planet, things about climate change, the kind of trade-offs you have to do, fisheries, and very much about equitable access to all of these limited resources, I would say, food security, water availability, and in general a healthy and productive environment for us on the planet. Going from 7 to 9 billion people, it's not going to be easy. That is, I think, where a lot of the challenges sit. And I think it ought to be informed by us, the science community, and the observing community. Last but not least, it's a transformational challenge. So this is about the transformation processes themselves. How do societies transform their behavior? How can you go to a more sustainable energy system in Europe, in the United States, Canada, China? But at the same time, how can you allow for global development in Africa, Asia, and other countries around the world, the First Nations here, maybe in Canada? It's about innovation and ideas, and it's a lot about governance. So here, these are challenges in some parts of the world about megacities, about development options, trade-offs, emerging technologies, efficiencies, but also about policy, incentives, the legal systems, as much as enforcement. And I think some of those you will encounter also have a direct bearing on observing systems. Now, if you want to have that science agenda working healthily, effectively for all the scientists around the globe, some arrangements have to be made which will be certainly outside the scope of future Earth. And these are the so-called cross-cutting capabilities, things that the scientific community needs to do its work. And the first one is observing systems, because clearly the scientists themselves cannot organize all the observations that they need to make progress. So these need to be trade-offs and handoffs with global observing systems, for example. There's data systems, there's modeling, and many other things, but I just highlighted observing. So clearly Future Earth is very interested in observing capabilities, but it sees it as a partnership arrangement between those who are doing it on the global scale and us in the science. That leads me into observing systems, and I want to spend a few minutes to discussing with you how the ocean community, the global ocean community that has organized and in thinking a little bit or shifting their thinking a bit on how we want to sort of organize our ocean observing in the future. In 2009, we had the second Ocean Orbs conference, 10 years after the 1991, and we realized that we made a lot of progress in the sustained observations of the ocean or ocean observing in general. So our summits only happen once a decade. I'm very impressed that you are planned to have them every other year. That's maybe a good thing. And we've developed a new framework for ocean observing that gives us some best practices guides on how to do it. And again, we were wondering who's going to pay for all the expensive ocean observations and why do we want to do this? And I do like Jackie McGlade's quote from the European Environmental Agency. Her job, the European Environmental Agency's job is to take care of the environment, be the stewards, and we must measure what we want to manage. That is very clear to most managers. Without a decent observing system, you just cannot manage the environment, and that's true in the Arctic and everywhere around the globe. However, how to do that? So the new framework for ocean observing is rather simple. It starts with an input, with the requirements. What are the requirements of an ocean or an Arctic observing system? And then here is the process, the observations themselves, that most of us in the room have a lot at stake at. But none of this is helpful if you somehow cannot deliver the output that meets the requirements. Because those who want to fund that middle part are driven by this and they need some answers, right? So that is the simple system that we set up. We certainly elaborate on that a bit more. So the requirements come to us from the sciences, from other things. I'll show you some examples. And then the question is what to measure and how to set priority. And I think the next 3 days you will engage in this debate. So the ocean community says it might be a good thing to actually define what we call essential ocean variables. And I'll say a few words about that in a second, before we talk about the networks. Because once you understood what it is that you need to observe, then you can engage in what some people call the trade space to have different networks, competitors, think about remote sensing, in situ systems, how to best observe the essential variables. And as importantly, make sure that they have a data system to it and an information system so you can actually provide the knowledge information that was asked of you, the big U being the system. Now in the ocean, again, it's the essential ocean variables that we're just about to generate. It's possibly an overlapping set with the essential climate variables. That is the framework that the Global Climate Observing System has been using for more than 20 years now. But there's others which have maybe some overlap with weather, with biodiversity, which are neither pure ocean nor pure climate. So we need to define a bit what exactly it means for the ocean, and I encourage you to think about maybe that for the Arctic. As we think about how observing is done in the ocean, we're introducing the concept of readiness. And I heard a lot of references to that, but not in that systematic way up to now. That is, universities, innovators, industries, you're doing the concept, the engineers. You get the next platform, the next sensor, the next thing you think should be important to you. And it's very important in an observing system to have concepts, innovations, new ideas. And then maybe the international science community goes about and does a pilot. You use vehicles like the IPY, where you try a few things out and see how they work in the Arctic. But once you've done the pilots, I think that was Peter was mentioning that, if you've done it for a year or two, then you really have to think about, are they mature enough to become a sustained, maybe more operational part of the observing system? But it's good to realize you need all three of them at the same time, because that's the incubation machine that always gets you from the new thing to the sustained thing. And sometimes you want to review what you have in the mature system and maybe new technologies replacing existing ones. So we offer up that as a framework how to think about observations from the concept to the pilot to the mature. Now the societal drivers we think for the ocean, I'm sure for the Arctic already have, go much beyond maybe climate and weather. Fisheries has been always there. There's more demand for real-time services in the ocean. And there's new things that have to do with ecosystems, with sustainability, so on. So we think the demands on the ocean observing system are growing. And in the Arctic, you've seen that already in a big way. And we think about these sort of things with people like Albert Fischer, who is the GOOS director at the Intergovernmental Oceanographic Commission in Paris. So maybe that can help you with your thinking a bit. I'm going to go to give you some examples. So sea ice, I'm sure, if we had to think about an essential Arctic variable, how could sea ice not be one, right? So I'm sure it's one. I'm giving you some slides from how AVI, the Alfred Wegener Institute, goes about that. So they have, which I think is a very typical system, how the physical community would think about it. You have thickness, radiation, texture, surface signatures, and then you have sort of international programming around that. That's typically how we in these groups operate, and it's focused on a particular aspects of sea ice, which, as Peter was saying, I'm sure we've operationalized some of that already successfully, maybe not so much the thickness, but other parts we are well at hand. But then there's also discovery. So just as an example here from Antje Boetje's paper, this is sort of the interaction between the ecosystem and the sea ice, and I think they found some fascinating new algae growing off the sea ice, which you can hardly see here, but they're very long. They fall right down to the seafloor at 4 kilometers depth and feed benthic communities. Is that rain of material a new thing? Has this been there over the last decade? Will this continue? These are the discoveries that you can do with observations and sometimes even with observing systems. I'm showing you another discovery in a very different context that's more my world. Here's a picture that you know well, that is the global temperature change over the last 120 years or so. Here's the ocean component to it, and people like myself and Jean-Claude and so we're very interested in these decadal swings and forecastability and trends and all of that. And now what I'm going to show you is just the trend over the last 100 years projected on the globe for each region. That is work with my colleague from Qingdao, Lixin Wu. So we've been using global sea surface temperature observations over the last 100 years, which you can't have everywhere. So you have to put them into models, do data assimilation, do some fancy analysis of them, and then you just color code the trend. And what we in the ocean community found fascinating is that if the globe was warming at a constant rate, the color would be this light blue here with the black bars. That's the global rate of something like 0.6 degrees per century. Now you see there's some parts of the globe which are close to that, but look at that. The Gulf Stream, the Malvinas, Falkland Current, the fast currents in Australia, Kuroshio system, Angola system, all major western boundary current systems have warmed 4 times the rate, 3 times the rate in the global system. Why the hell is that? It's discovery. We have no real idea. We think probably the boundary current systems shifted towards the poles and carried the heat with them. That's the most plausible explanation. So I'm just telling you, sometimes if you engage in boring long-term observation, new discoveries can also be possible, and they're quite relevant, actually, if you think about the regional signatures of change. Now, if you do want to make progress, I think, on the global scale, in the Arctic, in the global ocean, robotics is the only scalable way that we know that complements remote sensing. I can't imagine that we're going to have research vessels all over the planet or over the Arctic with icebreakers, 10 icebreakers operating at the same time. It's not fathomable for me, at least, so I think it'll be. And the robotic systems that we have been using, and you've all seen Argo in my community, it's fascinating. You get the globe together, and we have something like 3,600 robots every 10 days taking an observation over the upper 2 kilometers of the ocean. That is massive robotics. It's just about okay to sort of determine the state of the open ocean. It's not too many of the robots, but at least it's a great start. And what you can do with them, now you can look at important other ocean variables for oceans and climate, like heat content. And I'm showing you here 50 years of data. And this is the upper 2 kilometers. And what you can see here, I want to get your attention to the arrow bars. Here's where the Argo decade comes in, about here. We pretty much halved, or 20% of the old arrow bars are now our new arrow bars because of the massive indulgence of robots into the observing system. And what you might find fascinating, at least I do, is if you look at that piece that is below 700 meters, that's the black line here, you can even see observed warming below 700 meters out of the noise. So global warming is not just happening at the ocean surface, it's actually happening also deep. And we don't even know how much it is warming below 2 kilometers because we don't have an observing system in place in the ocean. So we're guessing a bit with a few hydrographic snapshots. Robotic systems have been pioneered in the ocean. These are cables. This is one that might be put in the Fram Strait at some point, maybe not. We'll see how finances go. Neptune, Canada is not in the Arctic, but things like that could be a piece of it, and then it allows you to do other type of observation, in particular benthic ecology, sort of community systems, things that are hard to assess otherwise, and you might want to have robotic systems or cable systems for that as well. So all of it, at the international level, we have in what we call the global observing system here with many components, and I'm sure you SAON experts know all of those. I'm sure you know the Global Cryospheric Watch and the global other systems. But what I do want to highlight, where are the observations for the social scientist? And I'm hoping for the roundtable discussion this in an hour or so, that the social scientists will tell us and tell you what it is they want to do the integrative science. Because quite often we find that those data are not as well organized or easy to access. 2 words about outreach and education. I have no idea how much of your Arctic observing system is on my iPhone. Maybe a lot, maybe little, but I think I like the SAON website a bit. I mean, already there was some beginnings of that. I think that's where the public is going to check on you. And if they can't get easy access to your information, they say, why are we paying all this money for this Arctic observing system if you can't get the information? And I don't think they want the raw data. They want the information. And my second to last slide is one that I'm showing more often. It is about data availability. I go quite often on record saying I hate patents. And the reason why I do that, because I side with Thomas Jefferson. The field of knowledge is the common property of all mankind, and not just the rich nations or the lucky guys who work in laboratories. And any discoveries we can make in it will be or should be for the benefit of every other nation as well as our own. I think we in the developed world should take a hard look at whether we actually do own all the networks that we think we own, and whether it is not our responsibility to make observations in those areas or regions where people can't afford to do them, and whether it's not our common responsibility to make all that information available for their decision-making as much as our decision-making. And I don't think it's a good idea to patent your results and make them only available to those who can pay. So my last slide is for you. The Marine Board of Europe and many others certainly are paying attention. The Arctic is of interest not just to the science community. It's, I would say, of interest for 2 regions. It's a bit the canary bird in the mine, meaning changes are happening fast, as Peter was showing. But I'll tell you, the other reasons why Europe is interested, because they want those resources. And that's why Canada is interested in the Arctic. We've got to be upfront about that, and I think they should be a partner rather than the other ones? And we have to think about how to do that. We can think about observing systems. I love this diagram from the mosaic observers activity here. But then what are the essential Arctic variables, those you want to put the big resources at for sustained observations? Is there agreement around these groups what they are? Are there 25 different ones? Are there 10? Can you prioritize them? And once you know what it is, then you can start about the observing systems and the networks to figure out how can you do it in the most cost-effective way. Thank you very much for your attention.